Literally a light falls on me and nothing happens.
Okay, my plan, let's see, do this. 7, 3, trying to get there. So we did 1 and 2 already yesterday in class, right? So number 3, it says, the Denver Post, January 18th, 2014, stated the average cost of a room, hotel or motel was $81 per night. Okay? Suppose you're a reporter for a competing paper and you question the statement by the Post. Okay. I think we worked through that. Wait. Am I on the right page? Yes, okay, all right. Let us hypothetically say that you use the internet to get a random sample of 28 hotels and motels. Okay. You found that the price per night of room of the sample mean rate was $57.94. Sample standard deviation was $8.73. Assuming the prices are normal, use this information to compute a 99% confidence interval for the mean room rate for all Denver hotel motel rooms. Okay, so this is problem number 3, and we are saying that we realize that 28 we're going to use a degrees of freedom of 27. Okay, why are we talking about degrees of freedom? What's going on here with this problem? T is what? It's less than 30, so it's T-score. Good, I love it. All right, so I think we have enough information to go with this problem. So degrees of freedom, how does degrees of freedom work with our table? I forget. So we're going to go to what? 27, and we're looking for a what? 99%. So you can either look at the very bottom to find 99%, or you can realize that both of the tables are dealing with 0.05, so it's going to be the same thing. So we're doing degrees of freedom 27. And 99, so 2.771. So E equals 2.771 times, what goes in the numerator? Standard deviation, which is $8.73. And what goes in the denominator? 28, but what is 28? Square root of 28. So you go through this problem, you find that this is going to come out to 4.572, which means I'm going to take the 5794, and I'm going to subtract this, and I'm going to take 5794 and add that, which gives us, I think if I did this right, 53.37 to 62.51. Okay, so what this states is that we are 99% sure that if we were to, or we're 99% confident that if we were to generate the random sample of the same sample size of hotel motel rooms, that our information will fall between those two things, which is close to $9, a little over $9. Okay, is the Denver Post of $81 in your confidence interval in Part A? Would you suspect the Denver Post average to be too high or too low? So is the $81 the Denver Post says, the Denver Post claims this is the cost of hotel rooms, motel rooms in Denver. So this versus that's way outside of it. This was based on a 99% confidence interval. If it's a 99% confidence interval, that would say that I am not confident. I have 99% confidence that if I were to replicate this test again with the same amount of people, same amount of rooms and things like that, that my data would fall inside of that. I only have a 0.05, I have a 0.5% chance, or 0.005 probability that if I did this again, it's going to fall outside, and falling outside at 81. So Denver Post was too high because that $81 is way outside this confidence interval. Okay, so you discredit what Denver Post had done. Number 4 says a coffee machine dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the amounts measured in a random sample of 20 cups. So problem number 4. So we have 20 cups. And then these 20 cups, we're supposed to be getting 10 ounces in each cup. It's going to slightly vary. So you need to plug that data into the calculator, do the one variable statistics to get the information out. So we're going to find by doing that n equals 20. And then we're going to have our average is 9.845. And our sample standard deviation is 0.199. Okay? What are our degrees of freedom on this problem, and why am I going with degrees of freedom? It's less than 30. Okay? So, hey. Oh, wow. Thank you. Gotcha. So a few things that we have to look at here. Do the three assumptions apply? It says random, so that's got to be yes. Independent. What do you think? Yes or no? Is it independent?
Sure.
Why?
Why not?
I will tell you it's not normal. Why can I say it's not normal? So, and then what about the independent? What was the test for independence? Do I? Which is it?
10%.
10%? Sure?
Yeah, 10%.
Okay. So are those 20 cups less than 10% of the whole fill of the machine? Okay, I imagine if you were to have a coffee machine that actually dispensed a cup then coffee, I imagine you would load that machine with a whole sleeve of coffee cups, however many that might be, and then we're going to sample 20 of those cups from this particular machine. Okay? And I'm just thinking because it says a coffee machine dispenses coffee into paper cups. So, you know, I think you could argue it a few different ways, but I would imagine that 20 cups of coffee out of this machine that has a water source, has coffee that's in it, and has cups that are in it, I imagine 20 of the cups could be under 10% of what the entire volume of this machine could produce. I mean, it wouldn't make sense to me that you had a machine that you would come by once a day, refill it, leave it for the day, especially if it's some real busy area where a lot of coffee is taking place. So I'd say that all works. The reason we're using degrees of freedom is because we're talking about 20 cups here. So I have 19 degrees of freedom. So my t-score that I'm going to use, we want to construct a 90% confidence interval. So we find that with the t-score. So we get 1.729. So I'm going to have E as 1.729 times the 1.199, which was our standard deviation, over our sample size of 20. And if we do this, we're going to find that this comes out to 0.0729, which when we so this is for the 90% confidence interval. Okay, then we say construct a 99% confidence interval. So if I do a 99% confidence interval, this is the only thing that's going to change on us, and that's going to change to 2.861, which then is going to give me this score of 0.1273, which means 9.718, comma 9.972. And then, do you think the customers are being shortchanged? Why or why not? Why or why not? They're supposed to be getting 10 ounces of coffee. Are they being shortchanged? Yes. Both our 90 and our 99 percentile confidence intervals do not include or don't go over 10. Now, some of you might say, big deal, you're talking about a smidge. Do you think there's any companies out there that might, if they could, get away with just giving you a little bit less? Yeah. Gasoline company, boy, wouldn't they love that if you weren't really getting 1 gallon, but you're getting like 0.9996 of a gallon? They'd be banking off that. So they have a system in place that's supposed to regulate the dispensary rate of gasoline pumps. Yeah.
Isn't that good with octane levels? Like if you do bad gasoline,
Well, I'm not talking octane. I'm talking just the volume of what comes out of that spigot. It's supposed to, so if you look at that machine, there'll be a little sticker that's over. It's like they kind of put it over where you could open up the guts of the machine, and it'll tell you when it was tested. And it has to fall within a certain parameter, certain margin of error before they say, you know what, this machine needs to be adjusted, it's not dispensing appropriately. And they do it both, and the gasoline company wants to do it 2 ways. One, they would love to sell you a lesser amount per gallon, God bless you, and still charge you per gallon, but they also, on the other end, don't want to be going, I don't want to give you more than a gallon and you're only paying for a gallon. So it's kind of working for the advantage for both the gasoline company and for the consumer to be accurate that we are truly getting a gallon. Okay, and that's what we're doing. So a coffee machine, is this that big of a deal? Is this coffee machine, are they really going to become like trillionaires because they're dispensing between 9.768 and 9.99 or 9.922 with 90% confidence interval or the 99% interval? If they're both below 10, is that really that big of a deal? And most of society will say, no, it's not that big of a deal. Can I tell you what the difference between what a 9.972 cup of coffee looks like versus a 10-ounce cup of coffee? No. It's so very little. But if you are advertising that I am giving you 10 ounces, you have to make sure that it's going to be 10 ounces. Okay, you don't want to shortchange them. Back a long time ago, and there's a couple movies I've seen that do this, but I've heard that people have done this, is they used to slide, a lot of times it was just a matchbook, underneath the scale at the butcher. The butcher didn't used to go get cold cuts just from the supermarket, but you could go in and the guy would slice you, a whole bunch of roast beef, and they put it on there, and they'd stick a little matchbook on the backside of the scale to where the guy who was cutting it couldn't see that matchbook. And what that was doing, it was pushing the scale up a little bit, so you were actually getting a greater amount of the meat not paid for. So it was very dishonest. But I don't even know why that came to mind. I was just thinking of I saw it on a movie not too long ago, and then I remember people always talking about, oh yeah, this is what you could do. And I always thought as a kid, why would you do that? But all right, 7.3. How do we feel? Number 5 on that page, on the next page, it's going to be done the same way. Plug it into the calculator. You're going to be able to find your sample size being 16, your average being 2.71, and that has to do with GPAs and such like that. Okay. I'm just going to move on to 7.4. Is that cool? Anyone need to stretch? Anyone need to poke your neighbor in the eye? Yeah. Okay, will you remind me once I'm done? Perfect. All right, 7.4 notes. Means versus proportions. Means, you measure something and find the average of that measurement for the sample. That's the means. Proportions, you count how many of your sample fit to certain conditions, find a percentage. Okay? So decide whether the following scenarios are means or proportions. You want to find the average weight of a Creek football player. So mean says you measure something and find the average of that measurement for the sample. So yeah, we can do that. Okay, so that would be means for the first one. You find, next one says, you find that 30.2% of senior guys hit snooze on their alarm clock this morning. That's a proportion. And most of you probably hit snooze. I don't like to hit snooze because, I don't know, I get up grumpier. Oh, you guys want to hear something freaky this morning? So you guys already know, because I've told you, that I get here way too early. It's like 5 after 5 this morning. I'm at the intersection of Dry Creek and University, turning left on the University to head north to get to Bellevue, right next to Arapahoe High School. So I'm kind of sitting there, and it's one of those where you pull up to the light going, really, it changed red. As I pull up, there's nobody here. I'm sitting there, and we have like this homeless lady that she walks around everywhere. She like walked right behind my car, and it was like, I'm not really paying attention, there's nobody out. And she, like, right as the arrow goes for me to go, right in my rearview mirror, I just caught it out of the top of my eye. I see this woman, she was blasted by my car. It scared the hell out of me because there was supposedly nobody around, so I don't know what she was doing, but this lady, she lives over in our neighborhood. She walks everywhere, and supposedly she's homeless. And I think it's sad, but again, she scared the hell out of me. 5 o'clock this morning. So, okay, back on the subject. Sorry about that. You find a sample of 50 seniors, and you find that 42 of them are planning to have a grandparent at the graduation ceremony. So I'd say that's proportion because you can do them 42 out of 50. Okay? Okay, you count how many of the sample, certain condition, you find the percentage. So 42 out of 50, which would come out to 84%. Let's see. You sample 40 seniors, and you find that they apply to an average of 4.2 colleges each. Means you measure something to find the average of the measurement for what you sample. Proportions, you count how many of the sample fit into certain condition. Means or a proportion. Okay. Incoming freshmen in college. The average ACT score is 22.9. You measure something that finds the average of what the measurement for the sample, or you count how many of the sample fit into a certain condition, you find a percentage. 22.9 the percent. So I think that one's got to be means. Okay. So going back through a few things. So from 7.1 of this chapter, 7-1, we talked about the Z interval. Okay? And you had your confidence interval, which was X bar plus or minus a Z score times standard deviation over N. And this portion right here became known as the standard error. Okay? So, there's one thing you have to fix on this one. It says conditions are SRS, so a standard random sample. Population is, I don't know why I went 10 times N. It should be the population on that. You should change this to this. I don't know if it was a misprint or what. Okay, and then the population is normal if N is greater than 30. So change the 10 times N for the population. Make sure you show that N is less than or equal to 10% of the population. Okay, so things about the Z interval, obviously you're using the Z-score. We found that Z-score has a neat place now that's easier to use because the Z-score falls on the T-table as well as the very bottom row. So you can find that pretty easily. So then you have 7.2 talked about the T interval one mean. Okay. So you know when you only have the sample standard deviation, so the sample standard deviation takes place. Okay? And then you have your confidence interval is going to be x bar plus or minus t s over the square root of n. So this portion right here is the standard error. And things here. So you have SRS, your population is a little bit different. You're going to use your t-table. So your sample standard deviation. So SRS, simple random sample, yes. Population, this should still be, the n is less than, change it to this, of population. And then this is not known. And again, this is where our flow chart in the population is normal because you have n is greater than or equal to 30. So either of these take place, we're going to t. So remember, I'm going to go back to our flow chart real quick. So, normal population. You've established this. So, you know this as a yes. God bless you. Z-score. If this is a no, but n is greater than 30, you're going to use Z-score. If this is a no, then you're going to use the t-score. Okay, so that's the flow chart that we have to use, which will help us through each of these. So, yeah. Yes. Okay, so populate. That should be not. Okay, so that's where that t interval is going to take place. So that t table should take place. Then the z interval for one proportion. This is a smidge new on what 7.4 is going to be. So, z interval for one proportion so your confidence interval is going to be p hat plus or minus z square root of p times q over n. And let's figure out what the heck some of these things mean. So p hat is the probability of success of our sample. Okay? Just regular p right here is the probability of success of our entire population. And then q is the probability of not success of the population. Okay? And then, you guys know what C is. So N, sample size, we now have that up there. Okay, so simple random sample, population is less than 10% of the population. N times P is greater than 10, N times Q is greater than 10. Wait, that's different than something we've done, but we've seen this before. What did this mean? What did that mean? I forget. P and Q is P is the probability of success, so like 30% chance it's going to happen. Q would be like 70% it wouldn't happen. Okay, either won't happen or will happen or won't happen, but you have those things. What was the N? What did the N deal with? Yeah, sample size. So let's define N is our sample size. So this has to be a larger number than 10 as well as this. So if you had a 30% chance that something was going to take place and you're talking about 100 in your sample, you're talking about 30 items. It'd be a 70% chance it doesn't happen, so N times 100 is 70. Both of those numbers would be bigger than 10, so this is going to give us our test for independence. Okay? And I can now jump through the examples real quick. Oh, dude, I got so much time. How did I get so much time today? I'm slowed down. Sorry. Probably freaked out about that. Homeless lady scaring me. Okay, a company is curious about what percent of the product will be defective. A simple random sample of 500 products contained 30 defective products. Okay, so you have 500 is your N, and 30 don't work. They're defective. So some people might say, well, shoot, let's go with the cup is half full versus half empty. That means that 470 of them work. Great. Whatever makes you feel better. So, what is P hat? This is the probability of our sample. The probability of success. But the probability of success in this problem is what? Defective. So 30 out of 500, that's our probability of success in this case. Sometimes that gets a little mixed message, which means 0.06 is the probability of that. What would Q hat have to be then? 470 over 500, you're absolutely right. And 470 over 500 would be what? As a decimal. This and this have to add up to 100%. 0.94. Okay? So we have both of those. What is the mean of that? We have that. What is the, we have to change standard deviation. We're going to change it to standard error of P hat. Standard error. You guys remember? So the standard error on this particular one is going to be P times Q over N. So I'm going to take the square root of 0.06 times 0.94, all divided by N, which is 500. And that's our standard error. And if we do that math, it's going to come out to 0.0106. Okay? So what is the probability that 30 or more defective products would have happened by random chance? Where do we have to go with this one? Oh, you're awesome. Yes. You have to use the NCDF, the normal distribution. So split this real quick. So I'm going to use the NCDF. Okay? And we're going to do it this way. So what is the probability of 30 or more defective products would have happened by chance? So NCDF 30 over 50, or 500, or I could have plugged 0.06 in. And I'm going to make that like 1,000. That's, a little bit more. And then it was what? What was the next thing on NCDF? The average. And we don't have a standard deviation on this one, but we have that standard error, which we'll use last. So I'm going to use this right here for right here. And then the very last part is going to be this, which we found to be this. Okay? So if you use this on the calculator, it's going to come out to 0.499, and that repeats for a while. So about 50% chance that 30 or more are defective products. Okay. Construct a 95% confidence interval. So I have E, 95%. We'll probably use a z-score. The reason I'll use a z-score is we're talking about 500 products. Even though 30 of those products, we're talking about our sample is 500, so that's bigger than our sample size being 30, so I'm going to use a z-score. And so a z-score at a 95% is what? Should be that. So now remember this is our standard error. So here, this would take place. So I know this is going to be this. So then that's going to give me, I can't read my writing, 0.0343. Which means I'm going to take my 77.52. Where'd you get that? I got it. I looked at the wrong one. 0.0208. And so, yeah. So I have 30 out of 500, which is 0.06. So this is going to become 0.06 minus 0.0208 and 0.06 plus 0.0208, which then will lead us to our confidence interval of being 0.039 to 0.081. Or you could change it to 3.9% to 8.1% if we were to duplicate this test, would be our defectives, which is great. Okay, before leaving the baggage claim of DIA and international flight, each passenger must pass through customs inspection area. Suppose we sample 400 people that must pass through the customs area and find 310 of them are stopped to have their luggage inspected. Construct a 95% confidence interval, and percent of people that will be stopped by the officials. So I will tell you that on number 2, we have the probability that you'll be stopped is this. So then this is Q. That's a Q, trying to be, is 90 out of 400. So you're talking about 77.5, 22.5, which means if you created your 90%, talking about 400 people, 90%, your z-score is going to be 1.645, and you can plug this in to figure out E pretty easily. 1.645 times your standard error, which is the probability P. Remember this. So we're going to do that on this one as well. So I have 0.775 times 0.225 over 400. And if you do that math, you're going to come out to 74.07% will get searched, and 80.9 to 80.93% So we are 90% sure that between 74.7% and 80.93% of people would be searched as far as these international flights go. And we're not trying to test whether it happens or not. And then a statistics professor done the same way, right? Whether or not they were registered to vote in a sample of 50 students, random samples from her 700 students, 35 said they were registered, finding 95% confidence interval for this. So you're talking about probability of that sample being registered, probability of not being registered. So we want to do a 95%. So that's going to give me E or Z equals 1.96. So E equals 1.96 times the square root of 0.7 times 0.3 all over the 50 kids sampled. And we're going to find that our confidence interval here, if we were to reduplicate this, would fall between those parameters. That would be good to go. All right. Utterly bored? Yes. 1 and 2, 7.4 we're going to do. We'll do 7.5 tomorrow. So today is Tuesday, tomorrow is Wednesday, and then Thursday we'll review, and then Friday we will test, and then Monday is senior ditch day, and then Tuesday, Wednesday, Thursday, Friday, we only have this class twice, like at 12:15 in the afternoon, I think. Whew. Crazy.